Hello, good day today. Today, this topic is random forest from machine learning algorithm. So it is the random forest algorithm is a popular supervised machine learning techniques used for both classifications, predicting a category, and regression, predicting a continuous value. It operates as an ensemble method, meaning it combines multiple individual decision trees to achieve higher accuracy and stability than a single model could deliver alone. And core mechanism on how it works, the random forest algorithm. Normally, the random forest builds a forest of independent decision trees through two main processes of randomness. Bootstrap the bootstrap aggregating, that is bagging. For each tree, the algorithm creates a new training set by randomly sampling the original data with replacement. This means some data points appear multiple times in a sample, while about 37% are left out as out of bag OOB samples for validation. So next is random feature selection. Instead of looking at all way available features to split and move, each tree considers only a random subset of features. This feature bagging ensures that trees are uncorrelated and prevents any single dominant feature from dictating the structure of every tree. And the final prediction classification, the forest takes a majority vote from all trees to decide the final class. Regression, the forest calculates the average mean of all individual tree predictions. Key benefits and limitations, advantages and disadvantages, reduces overfitting, averaging multiple trees cancels out individual errors, making it more robust than a single decision tree. Disadvantages are like high computational cost, building and storing hundreds of trees requires significant memory and processing power. Handles missing data, it can maintain high accuracy even with incomplete data sets through surrogate splits or feature bagging. And the disadvantages are like black box model. Unlike a single tree, it is difficult to visualize or explain the exact decision paths of a forest. Feature importance are like it automatically ranks which variable contributes most to predictions, helping in feature selection. And the disadvantages, on the other hand, like prediction latency, making a dead prediction requires transferring many trees, traversing many trees, which can be too slow for ultra low latency real-time applications. Common real-world applications like random forest is widely used across industries due to its versatility, like finance, fraud detection, identifying suspicious transaction patterns, and credit scoring, healthcare, disease diagnosis, and medical image analysis, example tumor identification in MRIs, e-commerce recommendation engines for suggesting products based on customer behavior, and cybersecurity detecting network intrusions and abnormal log activity. Implementation in Python, or like I'll be showing you at the end of the video, and we'll see the random forest algorithm in machine learning in detail. So random forest is a machine learning algorithm that uses many decision trees to make better predictions. Each tree looks at different more random parts of the data, and their results are combined by voting for classifications or averaging for regression, which makes it as an ensemble learning techniques. This helps in improving accuracy and reducing errors. And in this picture, you can see a class A and training data set, that is a model training happens in different data sets, class A, and class B. And so that is a decision tree from class A. It makes a decision, and again, it chooses the class A. And again, another class, it chooses class B. And it's trying to make a decision tree. And then what happens in the model testing? Bagging, voting majority, and then it passes down to the prediction output, and if it finds the class A. And high in the next thing, random forest effectiveness, or based on high accuracy, provides reliable and precise predictions. Handles machine values, the algorithm's robustness to incomplete data, and reduces overfitting, ensures generalization to unseen data, works with large data sets, efficient processing of high dimensional data. And in this, you will see, so single decision tree is there. You can see ensembles of trees of more accurate and robust predictions. And random forest, or what happens, predicts from a single decision path. First, class 1. Again, it tries to use the class 1 for doing the decision. And you can see that whereas class 1, and class 2. And each stages, it is trying to make some decision out of it. And working with random forest algorithm and create many decision trees, the algorithm makes many decision trees each using a random plot of the data. So every tree is a bit different, and the pick random features. When the building each tree is doesn't look at all the features columns at once. It picks a few at random to decide how to split the data. This helps trees to stay different from each other. Each tree makes a prediction. Every tree gives its own answer or predictions based on what it learned from its part of the data. Combining the predictions for classification, the final answer is the category that most trees vote for majority voting. Why it works well using random data and features for each tree helps avoid overfitting and makes the overall prediction more accurate and trustworthy. Key features of random forest handles missing data. It can work even if some data is missing, so you don't always need to fill in the gaps yourself. Shows feature importance. It tells you which feature columns are most useful for making predictions, which helps you understand your data better. Works well with big and complex data. It can handle large data sets with many features without slowing down or losing accuracy. Used for different tasks, you can use it for both classifications like predicting types or labels and regression like predicting numbers or amounts. Assumptions of random forest. Each tree makes its own decisions. Every tree in the forest makes its own predictions without relying on others. Random parts of the data are used. Each tree is built using random samples and features to reduce mistakes. Enough data is needed. Sufficient data ensures that trees are different and learn unique patterns in the rating. Different predictions improve accuracy. Combining the predictions from different trees leads to a more accurate final results. Implementing random forest for classification tasks. Here we will predict survival rate of the person in Titanic. So these are the steps. So I will show the video at the and how we can perform these, and I will also explain about the same. So at the end, we see the random forest for regression task. We evaluated the model's performance using mean squared error and R squared score, which show how accurate the predictions are, and used a random sample to check model predictions. Advantages of random forest. Random forest provides very accurate predictions even with large data sets. Random forest can handle missing data well without compromising with accuracy. It doesn't require normalization or standardization on data sets. When we combine multiple data trees, it reduces the risk of overfitting of the model. Limitations of the random forest, it can be computationally expensive, especially with a large number of trees. It is harder to interpret the model compared to simpler models like decision trees. So next I will talk about the program. Now we will talk about the forestry implementation. So we have to import the seaborne as SNS and load the built-in Titanic dataset. So that's the reason we are importing seaborne here. And next is to preview the data, you have to do the following thing like print df of head of. So this will print the data. And next, the part is we have to import the data sets like input pandas as PD, and next from learn model selection, import Titanic, import train underscore test underscore split to split the dataset for test and training. And from sklearn.ensemble, import random forest classifiers. And from sklearn.metrics, import accuracy underscore score and classification underscore report. And import warnings. Warnings.filter for warning, ignore. And Titanic underscore data is equal to df.copy. And Titanic underscore data is equal to here. What we are doing is like corrected from the surveyed to survey. So, so normally in data set it will be in capital letters. So here since you are using the data set within the library, so it will be the column name will be in lowercase. So next is in the X Titanic. So we are extracting the PC class, sex, age, SIB, SP, and parts and fare, etc. And Y the axis we are exporting the survey data. And so here what you're doing is you're trying to find the male and female data from the data set, and here you're trying to find the age of the person you're referring. Next, it trains here. It trains the data set and split the data set here, like. And next is it's a classifier. So random forest classifier. What it does is it's estimator. It loads and underscore estimated equal to 100 references and random state equal to 40. So out of classifier.fit, it tries to fit in the X train and Y train data. And Y pred, what here happens is the classifier predictions happens on the X underscore test. So here in the accuracy, you can see it will show us the accuracy of the data of this particular model. And classification underscore, like here it is classification underscore code, Y test and Y pred. And here you are printing the values of accuracy and classification reports, and also sample passengers and predicted survivals from the data sets. So this is the output. And so predicted survival, we are trying to predict it here. So it says did not survive. It means no one survived that out of the given sample data set. So thank you for watching.